Okay, yeah, thanks for coming. So the main thing I wanted to go through today was how to automate image processing and image analysis. And we're doing this in Fiji because it's a really accessible tool, I find, for teaching biologists how to script. And that's because there's less of a disconnect between, typing things into a command line and what those things are actually doing. And there's a lot of flexibility in terms of using functions in Fiji and seeing how they work and incorporating those into your pipelines. Before we get started, just in case you're not using automated techniques for image analysis, I think it's a really important thing to think about doing. I mean, I think many of you have probably had projects where you've had to count cells or endosomes or something, in tissue, and it's very tempting to, maybe you try briefly to do it automatically, and you have a little bit of trouble, and so you just revert back to doing things manually. And there's a lot of pitfalls in doing that. I mean, I'm sure you've noticed if you try and manually count something, especially, you should always keep a record of how you do that, ideally like annotated on an image. If you come back to it the next day or a week later, you may look at it and think, oh, maybe why did I count that? Or why did I count that in this one and didn't count a cell like that in this other image? And you'll be aware of all these sources of variability. And that can be just like your mood. It can be the ambient lighting in the room makes things more difficult to see on that particular day. There's a whole number of factors that doing things manually introduce. And so it's good to think about doing things automatically. If you can get them to work well, then they're far more rigorous. They're reproducible. You can give someone your images, give them the script you use, and they can get exactly the same result. And I think, for most things now, especially now that we have access to things like machine learning and deep learning, most problems that used to be just intractable are now accessible to almost anyone with just a little bit of effort. And so the idea of this tutorial is just it's going to be a bit of a crash course in just basic scripting, and hopefully a launch pad for you to sort of think about how you can tackle more complex problems. And then if you join next week, you'll learn how to incorporate machine learning and deep learning into these types of pipelines. So what I'm going to do is share my screen. And I'm running it in a Mac, but you can be running this on a PC. ImageJ works just as well on any platform. Okay, so hopefully you all downloaded the example data. These are just some small example files that we're going to work through. And so inside that example dataset folder, there'll be a couple of subfolders. And the first one we're going to look at is just this simple Z-stack of a neuron, some neurons in tissue. And if we open this up in Fiji, okay, so before we get into scripting, if you just need to automate something very simple, you should be aware of a tool just called batch processing. And you can find this underneath process batch. And in here, you can just put some commands that we can, if you joined last week, you would have seen how to record those. So like to give you a very simple example, a lot of times people want to create a maximum intensity projection of a Z-stack. And maybe you have a lot of three-dimensional data and you want a way to just screen through that very quickly. And one way would just be to run a script so that you have 2D max intensity images of all those 3D volumes. And the way to do that, just using a batch process tool, we can go into plugins, macros, and record. And this recorder will record anything that we do. So if I wanted to create a maximum intensity projection, I could just go into the stack tool here, Z project, and choose a maximum intensity. And this is our maximum intensity image here. And you can see over here, this is what we performed. And if I copy this, I can place this in the batch processing tool, and I can choose an input folder. That could be my neuron stack here. An output folder. I could make a new folder just quickly and select that as an output. And I could run that. If you want to do anything that's more complex and you want to have readouts of what you're doing and make measurements, then this is really not a sufficient tool to use. And this is where you can start to use a macro to do that. And so for us, what we want to do is go into plugins and say new, and create a new macro. And I thought actually before we sort of start to create a macro, there's probably a few things that you need to know to understand how to use this well. So many of the things that you do in ImageJ will give you a line here that will let you reproduce that, but not everything that you do will create a line. And this is where some people like get stuck in being able to use this as a tool for processing images. And so some of the important things we can look at, when you're running these scripts, if you need to ever print anything, you can just type in print. This is like a very basic sort of scripting thing that, in many different languages, just typing in print, and then you could put in a string command, like a very basic one like hello. And if I ran this script now, you'll get a log saying hello. The other things to just very quickly go over is things like strings and integers and things like that. So in any sort of scripting that we do, we might not want to actually, exactly type something in every time. And so we can assign, a string like a sentence or a word or a number to a variable. And so, very briefly, if I wanted to just assign hello to a variable like a, I could just say a equals hello. And I could put this just below. And if I run this now, we'll get the same result, but we're using a variable. And this way, this is very efficient because you can do different calculations and assign them to variables, and it can really like shorten the amount of things you have to type in. The other thing is, if you're trying to use these tools, you might need additional information about the image, or you may need to do things that just aren't appearing here. And the really great thing about Fiji, especially in recent years, is all of these commands are actually available to you via auto-completion. So if you want some information about the image, you can just start typing in get, and you'll see, already some like useful commands appearing. And so common ones that you might need to know is like, okay, what are the dimensions of my image? Maybe that's important to you, or how many channels are in this image? So you can type, all you have to remember is just to type get, and then you'll have a list of all the things you could, capture from that image. And, just to give you an example, I can say get dimensions, and these are all variables that are going to be available to us after we run this command. So I can now say, print width. And if I run this now, that's telling me the width of this image here in pixels. So this is, if you're trying to run something and there's some information that you need and you're not sure how to get it, just typing in get within the macro recorder here will help you actually, find usually a function that will get you that additional information. And probably the last thing that really is important to go through is arrays. And arrays are a list of numbers or strings. And we use these a lot, especially for image processing. We'll create an array of files inside a folder. And just to give you an example, we can create a new array just by saying a equals new array. And we should be able to even, we could give it a size here, or we should be able to give it some variables. Let's see. So if we have a new array, now I should be able to say print A. And if it's an array, we can select which sort of value or sort of element in that array. So if I wanted to print the first value here, which would be 1, this can be a little bit confusing if you're just starting this. We sort of work from 0 up. So the first sort of value or element in these arrays will be 0. So if I say A0, it's printing 1 here. And if I did 2, that will give us 3. And if you choose something that's outside of this array, so if I tried to get the third value, which would be a number that doesn't exist here, then we'll probably get an error. So it's saying that it's out of range. So I know, like, normally when we do sort of scripting, and teach people all the way through, we can spend a day or more. So this is a bit of a crash course, but hopefully you can keep up as we do the very sort of simple macros and work towards a more complex analysis script. So with that, what we can do is start trying to create a script that will just do a maximum intensity of this image that we have. And so, if we just had the image open and we captured, this basic command, if we run this, then we'll get that image just like we did manually. But if we want to do this in a more automatic way, we might need to tell it where this image is. And so this is just a TIFF file. So Fiji is very used to opening TIFFs. All you have to do is type in open, and it's looking for a path for where that file is. Mac, you can just right click on the image and hold down Alt. That will let you get a path name. I think on Windows it's Shift. So if you right click and Shift, that will give you the path name. And that way you can just paste in here the full path name for where that file is. And we need to put this into quotation marks. So either side here. This will now open up that image. And then we can run that. And if we wanted to save it, then we can just type in save, and we could give it a new path. So we could just, this is just a very simple step that we want to do for just one image. And maybe we'll give it a different name, or we call it like a MIP, so we know exactly what that file is. So I'm just updating the file name here. And if we run this now, it'll open the image, create the MIP, and it's going to appear in this folder here. You can see we've now created a new image. So that's like a very straightforward thing. But what we want to do is be able to start to do this for many images that are in that folder. So we can even create a better example. Maybe let's just delete this. We can copy and paste this so that we have two of these. Okay, so the first thing we might want to do is we just tell it the directory that we want to process. So for us, we can just type in here directory, or actually more often I just put input for this. And then we can use this information here. This is actually the directory we want to process. And from that folder, we want to get all the files that are inside that folder. And so we can say files. And ImageJ has a tool for this called, again, we're just using get. Get file list. Yeah, and you can see it's already populated here for a directory. We just need to tell it that our directory is called input. And that's going to get a list of the files inside that folder. Sometimes you'll have like an image sequence where you have the order of those is very important. And so you want to sort of sort those. And so we can do that by just typing in files again and say array sort. And then we can say that's the file. So this is like our list of files that we got from the folder. And then we're just sorting those files based on alphanumeric ordering. So that now it'll process the image 1 first, then image 2 second. Okay, so we have this list of files, and we want to be able to process each image one by one. And this is where we need to actually just process over the whole array of files. And to do this, we can create what's called a for loop. So, ImageJ actually can automatically populate this for you. If you just start typing for, you'll get, we can use, and even this one's fine here. So what this is saying is we're sort of looping through from 0 to 9. So we're starting at 0 and we're running through this sort of loop here. I'll just close the loop. So everything that's in here, we'll go through for 0, then we'll go through for 1, all the way up until we get to 9, because this is saying everything less than 10. And so for us, we can leave this as 0, but this where we want to stop is at the end of our the number of files that we have in our folder. And so a useful way of doing this is just to tell it that we have this array called files, and that has a length. This is like how many files are sort of listed in the folder. And so now what it will do is it'll process the first file, the increment will increase. So I will go up to 1, and then it will process file 1. And if that's the end of the files, then it'll finish the script. So once you know how to use this, then you can process many things very easily. And so now what we want to do is open up our first image. So before we had this sort of open, and we were sort of explicitly saying exactly what file. Now what we can do is say, open the file that's in the input directory. We can use a plus here, and then tell it the file we want. And so like in that example of the array before, we could say like, files 0 to get the first one, or files 1 to get the second one. But we don't want to be explicitly saying which file. We just want to say I here. And that way, whatever I equals in this sort of loop will be the file that gets opened up. And so just by doing this, it's going to open the first file, do whatever we want, and then open the second file. And so, when you're doing these kind of scripts, it's very useful to sort of just putting a little bit of commenting in so people know what's happening. In case you come back to this in 6 months, it might be very hard to figure out what you were even trying to do. So, you can use / just 2 forward slashes, and then you can sort of put in a comment here. So this is something that won't get, treated as a command. It'll just be for you to read. And so we could say loop over files, and then we can say like open file. Normally when you're doing something in a loop like this, we just use a tab. So we have a little bit of, it's more clear to read what's actually happening. And then we can put our command. So this is our processing step that we wanted to do. And then finally, so we can just put a general thing, processing. And then I guess we want to save this image. So we can then save this. And we can just, give it, we could save it in the same folder if we wanted to by doing like input plus we need to, instead of, we want to actually give it a different name. So if we just put files, this would be a bit of a problem because it's going to overwrite that file we opened. And so what we can do is add in some information at the start here. We could say MIP, and then put another quotations here. Whenever you're combining variables with strings in these sort of commands, you just need to remember to put a plus between them. So we're just saying here, it's the directory, and then a file name starting with MIP, and then the actual file name. I'm actually saving to an output file folder instead here, which is a little bit better. And so to do this, we can make a folder. So we can do this by saying file, and then I use a command mkdir, and we can make a folder inside our input directory, and we can just give it a folder name like max IP. And so we can refer back to this easily. We can just call this output, and then just type in this same command here. And we can actually put a / there so it's easy for us to address. And so now we've got our output, we're cycling through these files and putting max IP in front of them. And this should run for us. Oh, okay, it's because I've got the folder name wrong. And so now you can see, hopefully it's clear, this is our folder, our input folder, and we have our max IP folder. And now we have these results. I mean, these are just the same image, but we can easily check and open up the images. So the other thing that can be useful is when you're doing something like this, so we have our files here, we've got some making a command. Maybe we want to know how long this whole process is taking. So we can say start get time. And then after we're finished processing all these images, we can get the end of that time with the timers at the finish. And then we can say like, So the time it took is, and this will be in milliseconds. So if you wanted it in seconds, you could divide by 1,000. And if we wanted to print this, we could just say print and say like total time equals, and then put the plus and then time, and then close that off. And if we run this now, okay, and now here we're getting actually our first kind of problem, which I'll show you how to solve. This is a really common issue that will come up if you're trying to script. It's processing these images. Actually, if I just delete the results and I run this again, so it's working the first time, but if I run it again, I'm getting an error. And these errors can be very difficult to interpret, but it's actually, what it's telling us here is like it's trying to process this image called max IP, and it's having trouble putting a .tiff on the end of it. It's really just seeing this folder and thinking that it's an image. And so a really useful thing that we can do is just process only images. And this way, if you've got text files or folders or other things inside the folder and you don't want to process those, we can ignore those. And probably the best way that I can help you with this is I'll just share a function with you that deals with this. Maybe I'll put this in the chat. So whenever we want to do something in scripting, if it's complicated or it's multiple lines and we're going to be doing it repeatedly, we don't want to have to just keep writing that every time we do it in various parts of the script. So what we do is create a function, and this is a really just a good example of a simple function. And the way these work in ImageJ macros is you put them at the end of the file. So I can just paste this into the bottom of the macro, and just so there's various ways to check for if it's an image or not. In this case, the function is looking through the list of files that we have and just checking, like, does it end with TIFF or ND2 or LSM or any file that we care about. You could add files in here if you wanted a different file to be detected. And then after that, it'll return the sorted list of files. And so if we have this function in our macro, I can just copy, this is the command that we would call to use this function. I can just put this up here actually. So where I have files, get file list, I can do it here. So instead of just sorting the files, I would sort them and then I would just select the image files inside that folder. And hopefully now if I run this, where it's not giving us that error anymore, even though that folder is there. And so we're just specifically targeting the image files. This is our sort of total time taking here. It's really, you can see it's a little bit messy. Like we're running this and the images are appearing, we are taking care of closing them. Actually, I should explain this to you as well. So to close images, there's actually a few useful things here. You can close and you can type in a specific name of a window that's open if you just want to close something specifically. A useful one is close others. This will just keep the image that you have open and close everything else. And this is really useful if you're processing big data sets, but you're sort of focusing in on one image that you wanted to treat out of that data set. And close all just closes everything, which is a really great way of just cleaning up the workspace. So we're closing the images here. But you can see, like, this is a very small macro. It's taking only a second or two, but you often want to go a lot faster. And for a lot of things we're doing in biology, doing things with the macro, especially if you start using batch scripting, which I'll show you in a second, is fast enough for most of what we're doing. If you need to go really fast, then you need to start doing some things in JavaScript or maybe in Python. But just switching to a batch mode is going to give you a much faster result. And it's very easy to do. We can just before we start processing the images, you can just do it here. We can just type in batch. And we want this one here, set batch mode argument. This is where we can turn batch mode on or off. And what batch mode does is it runs everything without displaying it, because displaying it is one of the sort of heavier things of, working with these images, is rendering the images. So we can just say set batch mode true. And if I run this now, you can see the total time is 120. So it's already processed those images, but it's taken a fraction of the time. And so when you're starting to do this, like, I would encourage you just to remember to put in a batch mode, and it'll just run in the background. You won't have to see anything popping up, and it'll be a lot faster. Okay, so actually now we've got something working here. And you saw before we had like some, maybe we wanted to add something else in. So maybe I have this image and, this looks decent enough. And if with our max intensity projections, if I just press Control-Shift-C, should get my display adjustment. There it is. Actually, it doesn't look too bad, but oftentimes, if you want to get rid of background and get a slightly better, higher contrast image, we'll use something like background subtraction. And we talked about this a little bit in the previous session. So I want to run a background subtraction, and maybe I'll just make sure I have my recorder open again. Okay, here it is. So we could find out a good setting for this. Maybe we just need something. If you're not sure how this is working, a good trick is just, you can duplicate the image. So you just have a single frame, and maybe you just boost the contrast a little bit. And that way, when you're trying to see what this background subtraction looks like, it won't be just becoming too dark to see what's happening. Now I can put in a different value here, and okay, I can see like this is actually pretty good. As before, it was a little bit hard to tell if this was working or not. I could try a smaller one. Yeah, so 15 is actually even a little bit better. If I go too small, I'll start deleting the cells. So maybe I want that, but in this case, I want to keep them. So, okay, that works well. And I've got my rolling ball here. If we just copy this, it's only going to apply to a single slice. So I'll just quickly show you the command to, we need to tell it we want to do the whole stack. So if I run this now, it'll ask, okay, do you want to do the stack? I say yes. And now I've got, we could have just typed this in, but we just have to tell it we want to process the whole stack. Okay, so we can put this into our macro. Okay, great. And if I run this now, it's a little bit slower, but these final images will be a little bit higher contrast. Okay, so we have something working, but maybe we want to have a little bit of control over what these variables are. I mean, this is a simple macro, and we could just come in here and say, okay, for this data set, I really want to use a different background subtraction. I want to use 5 instead of 15. But it might be a little bit nicer to have something that's easier to interact with. And so for that, there are these things called script parameters. And I'll just quickly show you, I mean, the internet is full of useful information on how to use ImageJ for scripting. And this is the newer way of creating parameters, in a GUI. And it's a very simple way of creating a GUI. We don't spend too long on here, but they give you some good examples down the bottom here. So this is what you would type if you wanted to have to give an integer or a number. So we can just use some of these at the very top of our macro to start to sort of give, let's choose the folder with an interface instead of having to type the folder, and maybe we'll put in something to select the size of our background subtraction. And to do that, and actually a good thing too is if you're starting to make something that's a little bit more complex, I would always like put a title, script for creating MIPS or something, just so you know what it is. And you should always put your name. Maybe if it's something that's going to go into a paper, you would put the institute. So I would usually put something in the top like this. So I've got a date and some people know what institute we're working at. And then sometimes, if it's complex, you might want to put some information like, okay, it's going to process the stacks, it's going to do this and that, and what you'll get back is a table or an image, and that way, like 3 years later, when you look at it, it's very quick to see what's going to happen if you run the script. And the other thing that can be very helpful at the top of these macros is to put some initialization parameters. And so the ones that I often put in to make sure things will work, you can use a command called requires. And this can be the version of Fiji that you're using. I think I'm using 5.3 something, so I'm just going to put 5.3c. That way, if someone tries to run it and they're using a really old Fiji and it's not going to work for them, it'll just stop them straight away and say, okay, look, just update Fiji before you try and run this. The other thing that, actually, I'll put some of these other ones in a second so they're more clear, but it can also be useful to, let's see if I can clear the results. If we're going to make any measurements, we don't want to have them tangled up with other measurements that we've made before. Closing the log. But that way, like, right now our log is kind of populating with like things from before. If we run this at the beginning, it's going to give us a fresh log, and that way we don't get mixed up with what we were doing before. And another one is, it's good just to close all. Yeah, and I'll upload all these too. So, if you miss something, this will be recorded, but if you miss something, these will all be uploaded. I'll share a link later on. Okay, so we've done some basic initialization. Do we want to put some parameters in here to make this easier to work with? And these always start with a hash and then an @ For the folder, we can say label. This is a label so that people know like what this variable is going to be. So we can say this equals input data or folder. The value, this can be useful like to give it a value straight away. So it isn't just empty. So if you have a favorite directory that you're going to a lot, you could just put that in here so it goes straight to that folder. And we need to tell it what style this is. This is a directory parameter. So we just need to tell it here that we want this to be directory. Okay, and we're going to call this input because this is going to replace our input line here. And the other thing that we wanted to do is give like a variable for the background subtraction so that we don't have to keep typing that in if we want to change it. So again, we can put in that, and this is going to be an integer, and we can call this label background subtraction value. The nice thing about these parameters is they'll remember what you used last anyway. So this value, once we start using a different number, it'll remember that number anyway, but just to give it a starting value so it makes sense to someone. And finally, yeah, I often use a spinner for this. So the style will be spinner. And this is going to be like, we'll call this BG subtraction or something like that.
Integer spelling.
Oh, thank you. Yeah, that's right. So it's always typos. So okay, now we can type in a value here. Maybe we want to do 15, and we can choose a folder. So we want this to be our neuron folder. You can see actually, it's important to point out here, it doesn't have a / here. So if we run this, it might work, but sometimes you'll have a little bit of trouble with some things that you're running. And so the reason it worked is because I left this here. So if I try and run it now, it might have some trouble. Yeah, it can't find the images. And that's because it's trying to open this. This is the folder, and that's the image. You can see it's missing a slash here. And so the easy way to fix this is just to tell it input equals input plus /. And now if we run this, it'll process the images. Okay, so we've got like a working macro now that we have some initialization stuff. We have some parameters. You can sort of see how to put these in. And I would refer back to this if you wanted to put in different parameters. There's some really useful information on this page here. And then what we're doing is setting the batch mode on. We're getting a time. We're running this sort of very simple steps over the images. And then we're saying how long it took. And then that's it. It's wrapped up. And this is already should be quite useful to you if you're just trying to do, you know, max intensity projection, or maybe you're trying to sort images out or do anything that you would normally do manually in ImageJ. Like there's so many times where people can get wrapped up doing things manually, where just doing this could save them hours and hours of time. And so yeah, just keep this in mind. Like if there's something you're doing repetitively, this is a really great way of just getting that done without having to really worry about it. With that sort of wrapped up, we can move on to something a little bit more interesting where we're starting to segment cells. And so for this, we can just keep this macro open. Inside the example data, we have another folder here. These are TIFF files that of sort of multi-channel cells. So this is kind of, it's a simple example again, but it's actually a very common problem. So we have a population of cells that are here in green. And actually I can just press Command-Shift-Z to get the channels tool. I can sort of look at these separately. So this is the green channel. This is kind of a population of cells. They're all expressing green. This is a nuclear marker. And in the other channel is sort of a subpopulation. This is like a co-expressing population. So there's only some cells that are expressing this. I can adjust the level so it's a bit easier to see. So this is any kind of problem where, you know, you can see here now, these are cells that aren't expressing this other protein. This is any kind of problem you have in tissue where you're trying to quantify cells and check for expression. And this is something that like often people will try and tackle manually, but is quite an easy problem to solve with some scripting. And so the first thing that we want to do is, in this case, detect the cells that are the main population. And so what we can do is just split this image. Any command, I'm using the menu here, color, split channels. The really nice thing about Fiji is this is all searchable. So you could just type in split, and split channels is just here. So if you're really struggling to find a command you haven't used for a while, just remember you have this here. Okay, so these are my sort of the global marker. And the first thing that we do to try and make these sort of problems easier, if we zoom in, there's some texture in these cells. It might be some background. And so the first thing that, if we try to actually just straight away, if we try to apply a threshold, so you can bring up the threshold tool by using Control-Shift-T. And if we just try to manually set a threshold, so if I bring it down, I think in this image, like a good example is there's a cell down the very bottom just here. If I try and get that image, actually I can get it okay, but I'm starting to join these cells together. They're actually becoming a lot bigger than the nucleus. If I go back a little bit, you can see the nucleus is kind of this big. And if I go more to the left to get those other nuclei, I'm starting to measure in the cell. And maybe that's something I don't want to do. In fact, you can see here, if I keep going to the left, I can start to get the whole cell body. And then I start to get a little bit of background. I don't know if you can see it here, but there'll be some background in this image too. So that's okay. Like we can deal with this quite easily. the first thing that we can do is just filter the image so that we can just focus on the nuclei rather than any texture or anything else that's in the image. And a useful way of doing this, and we actually talked about this in the previous session, we want to keep the edge of this nuclei. So if we tried to do like a normal blurring filter, say like a Gaussian filter, let's just have a look. So if I try and let's make a big filter here and preview. This is actually a useful filter if you're just trying to count objects, because you'll get like a nice brighter center and it'll sort of drop off quickly. But if we're trying to preserve the edge, then it's much better to use a median filter. We can use a median filter here. And if let's just say we use the same size. If I go to preview now, you can see that like inside the nucleus is like much more homogeneous, but the edge is actually very similar to before I applied the filter. And so this is a really nice way of cleaning up the data without losing structural information on the edges of objects. So I'm going to apply this filter. We're just troubleshooting right now. So, usually what I'll do, I'll just undo this. I'll make a duplicate of this image. That way, like if I do something that I can't undo, I just can revert back to the previous image. I want to do the median filter again. Oftentimes, like we want to get rid of the background, and a really good way, as we've talked about this before, is to use like, in the previous talk, we used like a difference of putting a low pass filter to pick up just the background and subtracting that, or we can use just a rolling ball filter, like the subtract background. And we want to be pretty careful with this. We don't want any of these big nuclei to disappear. So we probably want this to be fairly large. You can see this cell here, like it disappears. So maybe I'll put this a little bit higher. Okay. So hopefully now I can get a better result with the threshold. So we could try and use a manual threshold. The problem you'll probably come across is if you try to use manual thresholds and there's differences in the data sets that are causing you to miss cells, it's much better to use an automatic threshold. And these are available to you just here in this drop-down menu. These are looking at the histogram of the data. So we talked about this a little bit in the previous session, but this is like a histogram is sort of plotting how many pixels are of certain intensity. So like we've got many dim pixels here. This is that peak, and then it drops off. And then we've got they'll be hard to see here, but they'll be the pixels that make up these nuclei. And these automatic thresholds look at the histogram and figure out where that cutoff should be between foreground and background. And oftentimes for these sort of projects, we'll use something called an Otsu threshold. This is usually quite good at picking the cutoff. You can see in this case, it's actually not so good. That's okay. Another one that's a little bit more sort of stronger threshold is Lee. That this will pick up them a little bit better. They're probably the two that I end up using most often for these type of projects. This looks actually already fairly decent, but if I just reset this, if you look at the boundaries, I'm still picking up some of the cell body. So like, in this situation, this is probably fine. But just so you're aware, if you're in this situation and you need to improve how well this mask is appearing over the cell or the endosome, and you're not getting a good result using a global threshold, which is what we're doing here, there are local thresholds that you can use. And just to give you an example, we can get this underneath image, adjust auto local threshold. Oh, actually, just as a brief aside, if you're not sure, like maybe you don't want to just use Otsu and Lee, maybe you want to explore other thresholds and you don't want to sit here just trying them all, you can actually just use auto threshold and say try all. And I won't do this for the whole image, it'll take too long. But if I just do a very small image, maybe I'm not sure what threshold will be good. I can go to auto threshold and say try all. And this will actually run through all the different thresholding algorithms and then give us an image. It may take a little while on this computer, but it'll give us a result that will show us how the different thresholding algorithms will perform for this type of data. It's working away here. Actually, here you go. So now you can see the results from the different tools. So you can see, down the bottom here, you'll see the different algorithms. There's Otsu here. This is Lee. So this is a good way of screening for that. All right, so for us, just to give a slightly better result, local threshold. Okay, some of these tools in ImageJ need to be working on 8-bit images. So these are especially a lot of the systems we have, we're working in 16-bit. You might just need to go image type 8-bit, and that will convert it down to a 8-bit image. Let me go back into adjust, auto local threshold. I don't want to try all. I know that this Bernstein one is a good one for this type of example, and we might just need to play around with the radius a little bit. So in these local thresholds, it needs to know a little bit about the size of the object, and then it will look, in the local area to figure out where the foreground and background will be. And you can see, hopefully, you just from remembering how the previous one looked, like this is much more tightly fitting around the nuclei. And so if I really cared about the intensity of what was in the nuclei, I didn't want to be diluting that measurement with some of the cytosol, then this would be a much better way of making that measurement. And because we have our recorder open, we've captured all these things. So what we can do now is start to build up what this script would look like. Okay, so first of all, if you're doing anything where you're making these binary masks, ImageJ can behave differently depending on how it was installed or what's being changed in it. And one of the common problems that comes up, and it may have actually happened to you if you were replicating some of what I was doing here, it can be a really annoying problem where the cells are black and the background's white, and you can have trouble sort of seeing what you're doing. This can be fixed by going into processing binary options and just setting some options. We want to make sure the background is black. And there's a few other things here that are important for some other image processing, but this is what we kind of want for today. And if we run that, we can actually get those sort of commands in the recorder here. And I'll always put those, I use 2 of them here. I'll just copy and paste. This is the one we just did. So background black. So the iterations here is like if we're doing dilation and erosion. Actually, we might talk about this briefly a little bit later, but just don't worry about that for now. And then just making sure the foreground's white and the background's black, because this can be something that can really frustrate you if you're trying to do scripting and it's not working on someone else's computer or a different computer that you're using. So just having these in here will save you a lot of trouble. Okay, so we've got these initializations in. We can leave this as it is for now. We're using batch mode. We've got our file folder. Maybe we'll just change this to output. Okay. So the first thing that we want to do is open the image. So we're doing that here. You can use things like, you can assign the file name to a variable. Like you can say A or image equals get image title. I actually, often what I do is I just bring the file in and then I rename it straight away. So, in a very straightforward example would be I just rename this thing in input. That way, like, because the image is going to come in as the file name and it can be different for every single image, and that can be a bit of a pain to deal with. So just having a very short name to call it when it comes in makes that whole pipeline much easier to deal with. And we have this image, just going back to the raw data. So these are our raw images. And first thing we had to do is split the channels. So here's our split channels command here. Like if you want to sort of replicate something in here, so right now, this is actually called 1.tiff, and I'd have to rename it to input to sort of replicate things the way I want to inside this script. It's really easy to actually just select just single commands or a few commands and run them without having to run the whole macro or script. And the way to do that is just select the commands that you want to run. So in this case, I just want to rename it and split it. And then on Windows, it'll be Control-Shift-R, or in Mac, it'll be Command-Shift-R. That's just going to run what I've selected. And so straight away now I've renamed it. And I can see here I've got C1 input and C2 input. And so the one that I care about is C1 input. So what I can do is I can select it. This is C1 input. If I don't care about the other channels, so maybe to keep things really streamlined, I can just say close others. And that way, like, it'll free up some memory if these are big data sets. And then we can do our processing. So the first thing that we did was our median filter. So we can just say filter. Where's our? And so this might be a little bit difficult for some of you to see, but I'm just copying from the recorder the median filter step. We did some background subtraction. I can't remember what we settled on. Maybe 20 or 30. We're not doing a max IP anymore, so I'm going to get rid of this. Okay, and then we have to threshold that image. So after we've done this, we can say segmentation. And in the end, like, the best one is actually to use this auto threshold. So we're going to put the auto local threshold. Okay, so we're sort of caught up to where we were. We have these cells now. Maybe we want to count how many cells there are. So a really useful tool for this is the analyze particles. And we want to actually set what we're measuring first. So if we go to set measurements, we use this a little bit in the first session. This is all the different parameters that we can measure if we're measuring particles. And we might be interested in the size of the cells. We could be interested in the mean intensity or the min and max intensity. Integrated density, this is a really useful one. This is the intensity based on the area. So if you just take the mean intensity of something, that's just telling you how bright it is, but it's also a function of how big it is. And so a really good case, these are images from a wide field microscope. So the measurements we're making of these nuclei are the measurements really of the total nucleus. So we can make a measurement now of really the total intensity in this nucleus. And we might be tempted to think that these small bright ones are actually expressing more protein, but really it's just the same amount of protein potentially in a smaller volume. And integrated density will let you get a measure of that intensity according to the area. And so that way, like, if there really is all equivalent expression, despite the size, those integrated density values will be fairly equivalent. So it's something to keep in mind if you're making measurements like this. And also another important thing here is we can redirect this to something. So maybe we want to count the cells, and our image is just a binary mask because we're basically, we've made this threshold. These images, once they're called binary masks, they have no intensity information in them. So background is black, and foreground in this case is 255 because it's an 8-bit binary image. But if we wanted to measure the intensity as well as the size, what we can do is say, analyze set measurements, and specify here what channel to measure. So we can say, okay, measure C1 input. That's the one that we really care about, that has the intensity information. Okay, so we can actually copy this so that we're really, we're making the same measurement every time we run this macro. And then we need to make the measurement. And so to do that, we can go to Analyze Particles. And it's important we actually have the image selected here. There's I would like encourage you to explore this like a bit later and just see, there's a lot of functionality here. So it's worth trying like all these different options, and I can show you the ones that are useful for us today, but there's a lot of functionality hidden away in here. The most like useful ones for us at the moment is, okay, we want, if these are all nuclei and there wasn't any, debris or anything, we could just use this as it is. Maybe I want to exclude these really tiny ones. Maybe they're not real nuclei. I could set like a minimum size. Or I could set a maximum size if there was big things that I didn't consider worth counting. You can exclude on edges, which is really useful because maybe I don't want to be including this in my analysis. It's not a complete cell. And we want to display the results. This way we can actually get the area, we can get the intensity. If I was going to do like really complex analysis with multiple channels and things, I would add them to the manager. This way, we talked about the manager last week. This is a way to like keep all the ROIs and use them for different processing. So we can actually look at what this looks like. I can even show like an outline so we can see like what this will look like. This is where the cells were detected. There's our measurements. So we've got our area. This is the intensity of that raw image. And then actually one more one that's actually quite useful for this. You can say in situ show, this will actually overwrite this image with the results. And the one that's useful is this count masks. This will give every single cell its own intensity. And that's really useful. So then you can start to say like, if we're doing more complex analysis, maybe we want to know like how many spots were inside the nucleus. Like fish analysis would be a really good one. If you're doing fish analysis, you want to be able to say, okay, there was 5 spots in this cell, 6 in the other cell. So using count masks, if I show you quickly what this looks like, we get an image. It can be a little bit hard to look at sometimes. A really useful lookup table for these is Gillespie on dark. And now we can see like every single individual cell color coded. And that color is actually an intensity. So this is cell 50, that's cell 49. So we can assign measurements to these cells if we wanted to. Okay, so we've got like kind of a few things going now that we want to do. That last one I think is pretty close to what we want. So I'm just going to copy and paste that. And in fact, whenever you're doing this kind of analysis, I prefer things not to be a black box. And so like I always try to write things in a way that I'm getting these either intermediate results or final results saved as well as the tables and statistics, because that way it's very easy to audit what's going on. And you can share that data so people can see like, how you've performed the analysis, how it looks. So I'm going to put the lookup table. This is that change in color that we applied. And finally, to, just like I was talking about, we can merge these channels. So merge channels. You can specify here. So this command, probably the best way to look at it, let's try and do it. Color merge channels. We can merge whichever channels we want. So this C11, it's a little bit hard to keep track of at the moment, but we want that channel definitely. We can assign them colors here, but we can tell it to just ignore the lookup tables. So if we wanted it to be, it's a little bit confusing. If I wanted this to turn into magenta, I would put it here, and I would say ignore lookup tables. So that way it'll become magenta, even though it's Gillespie on dark right now. But I kind of want to keep it this way. So I'm going to leave that unchecked. And I want to keep my original image as well. So I'm going to say keep C1 input. So this is kind of what it would look like. There's the result. So if you weren't sure what to type, you could just copy this now. And we could put that here. All right. So it's good to give these names. So what I would do is we're opening up the image, we're splitting it, we're running some filtering. Okay, so straight away we're filtering it. I would actually duplicate the image at this stage. So duplicate. If you're not sure what to type, let's just do an example. Control-Shift-D is duplicate. And we can even give it a name. Let's just say it's the nuclear mask. And if I look in Recorder, this is our command. You can kind of see like how you would type it in. So we had the first part already. You just need to put a comma and then specify what the title is. But especially if you're just starting, it can be really, really hard to know what those are, straight off the top of your head. So this is a really good way of doing this without having to invest a lot of time learning how to script. Okay, so we've made a copy. This is our nuclear mask. We're filtering it. We're doing the background subtraction. We're doing our thresholding. We're finding the particles. We're recoloring it. And so now we can just, as our output, we can say, combine the input, C1 input, and this is going to be exactly as it was written under the duplicate here. And then we're saving it. This will be our output. And maybe we'll just call it, yeah. Okay, and we had that results table. We've probably lost it in the background now, but there it is. So these tables, they're always called results. And a very easy way to save them is just to say, we can do it at the end here, somewhere shortly after we've done the processing. We can just say save as. We need to tell it that we're saving the results. So we can just say save results. And the path, well, it's actually very similar to this. We can just say this might not actually work because we can try it actually first, but this file name actually has, it'll be something.tiff. And you might end up with a file called .tiff.csv. We'll run it and see, but there's a better way of dealing with this. So actually, after we try this, if it gives an error, we'll fix it. And if it doesn't give an error, we'll fix it anyway. This is a common thing that people run into trouble with, and it's an easy way to fix it. So we have our merge image, which we're saving. So let's just do this here. So we're just saving the results immediately after, and then we're going back to the image, and then we're creating it, and then we're saving the image. Okay. Let's try it. So we'll run this. We'll choose our folder that has the cells. Okay, we've got our first error here. This is because we're trying to do that local threshold. And do you remember how it needed to have an 8-bit image? So this image is, we know this image is coming in a 16-bit. So we just need to say, let me just try bit. Yeah, so we can just say run 8-bit. That way that image is going to get converted to 8-bit. We don't care about losing the intensity information. And then it'll do the threshold. So let's just try it now. Okay, there's our results. All right, so we've got something working. There's our time here. There's our output. We've got, this is at least good. We've got our images. It actually worked. We've got this table as well. There's our result. So this is useful because now we can actually see like, okay, how did it work on some of these different images? Yeah, I can see like it's not actually doing such a great job on some of these bigger cells. And our table, there's actually another problem here. I think I have a funny feeling that we're not clearing the results. So what we can do, let's just make sure that we are clearing the results. So if you forget to clear the results, what will happen is it'll just keep appending the results. I can't remember if we did that. We can just quickly check. underneath analyze. Yeah, clear results. So we really need to do this clear results as well. Yeah, so the one we wanted to have included is, oh yeah, clear. So like, yeah, sometimes like it's very easy just to do that in case you can't remember what to type in. So this is our command. We just need to include clear here. Okay, so that fixed that. This file name issue, so it's not really an issue. There's no problem if you're running the script, you're still getting the files. But just so you have a good solution for this, for future things, there's another function that is useful. I'm just going to put it in the chat. I use this just to clean the image title. So what it does is just get the image title, removes the file format at the end, and just replaces any unusual pluses, minuses, anything that could be a problem in some of the programming that we do, and we'll create a clean file name. And so you can just use that. Where to use it is when we rename this. You say file name equals. So this is actually the function. Oh, okay. So I put the function in here. This is the command that we use to call it. And then it's just going to look at the image name, remove the .tiff, and then just replace anything and then return that new title. And so we can use it up here, clean title, and we're using the files. So whatever that file name is, just make it easier to work with file name. And we can use that down here. So when we're saving things, we can just say, file name, whatever. But now that we're doing that, we can even put like all these as suffixes. So we can just say plus file name, object count. It's important now because it doesn't have a .tiff that we put that there. So we have to say here .tiff, otherwise it won't know what to call the file. So let's just try this again. And I'm going to make this a bit bigger now. I think this was too fine. Okay. And what we should have, okay, so this is our first image. We open it up. Second one. Yeah, we need to fix that background subtraction, but otherwise it's working. And our counts now should be a little bit better. I think this is a shorter list. So we're really just getting the counts for each image. So the other things you might want to add on to this, actually, let's just quickly, just to make sure this is working properly. Oh, okay, so the reason it's not working here, we're setting this 15 as BG subtract, this sort of variable, but down here, we left it as 20. So to fix this, we just need to say, we need to put in some quotations here, 2 pluses. So it's going to use that variable, and then we can just paste the variable. So now whatever we actually type in for this GUI, it will use. And hopefully now if I run this one last time, it remembered that I typed in 30 before, which is good. And if I run this, we should get something that's a little bit more sensible as the output. Yeah, and now it's looking like, this is looking pretty decent. This is still a little bit, could be better. And that will be fixed by, we could increase it to 40 or something like that. It's really just the size of that filter. Okay, so just before we go on, we're doing okay for time. So just so it's easier for you to see what's happening in these type of things, maybe you're doing, I don't know, like hundreds of images from the spinning disk, and this is going to be running for a few hours. maybe just having the total time is not so useful. Maybe you want to have some information on how far you are or how things are going. So a very simple thing that we could put in here is just a command where we just say, just to give some feedback, we can just say print processing image, and we could put a plus and say actually we do I+1 because image 0 will be a bit hard to understand. And then we could say of, and we can put in here plus files.length and close that off. And that way, when we run this now, make that bigger, we'll run it again. So now it's telling us, okay, it's processing image 1 of 2, then 2 of 2. You know, another thing you can do in here is, if you don't want it just to keep listing what's going on, you can use a update to remind myself. Yeah. Let's try that. And so now it should just overwrite this. And that can be a little bit of a cleaner way of showing what's going on. Okay, so we've got that working. Another thing that we could put in here, you know, maybe this information is useful to you, but we actually just care about the total number of cells. So we could put in here very quickly, we could print something after we've done this. We could say print and the command that you can use for this is end results. And so now for each cell, actually just, I'm going to take this out now because it's going to be a bit confusing if I don't. We can run this and we can get, okay, there's 41 cells for this one and 26 cells for this one. I won't go into it today, but we could easily also make another spreadsheet where we're keeping track of the total number of cells. And at the end, we could have a results table where we just have like the file name, the number of cells, and the number of co-positive cells, something like that. To actually get to that other problem, so coming back to the beginning, we actually have these two channels, and we're interested in which cells are double labeled. So what we can do, instead of closing them here, we could get this image. We can measure C2 input, which is going to be our magenta channel that's only in some of the cells. And if we run this, if we look at the tables now, hopefully what we'll see is, oh, did I do this right? Oh, sorry. I need to do it here. I'm going to leave this as C1. I'm going to change this to C2. So we're saying measure, we're redirecting the measurement to channel 2. And that's our channel that's only in some of the cells. Okay, so we've finished running. If I open this up now, what we should get is, you can see here, we've got some rows here that are 0. We can go into this and say sort. You know, so we can quickly see here, okay, so we've got a few cells. These are going to be our cells that are just the green. A very easy way to measure these in here, we could do something where we look at what that intensity is and just say if it's you know, above 0, then it must be a double labeled cell. And so a way to do that, one way to do this anyway, is to, after we've done this analysis here, we can just do, so we could say, we can make a new variable called positive. We can make that equal 0. This is just an empty variable that we can start to count with. And we can make another for loop. So it's really important, if you're making another for loop, not to use the same variable that you used in this loop up here. Otherwise, there'll be some interaction and it's going to get very confused. So if you're using loops inside loops, this is a really common problem that people run into. Just change this to something else. We could, you don't have to use letters either. You could just say, you could give it something that you could remember more easily. Like it could be row or whatever. Just, it doesn't have to be just single variables. And I'm just going to change these all to J. So what we want is basically for all the results that we have, we can just check if each one of these results is positive or not. There's faster ways potentially of doing this, but this is a good way for you to see how these for loops work. So we can say, okay, for every row in that results table, if, and then we can get the result. So we can say get result. Let me close this. Yeah, and you can actually see how this works here. Let me just type it in again. Column and then row. So we can, if I just put this here, the column that we care about, I think we've closed it now, but I can open it. This is the column title. So we can, I mean, any one of these is useful. We could say mean or max, whichever one that we have in the results. I'm going to say mean. And the row that we care about, that's going to be row J. And we want to say, okay, is that above 0? Because if it's above 0, that means it's a double labeled cell. Maybe if there was some background that we hadn't removed, it would have to be higher. But in our case, the image is like very clear cut. There's no expression in the other cell. And then what we could do is just add that up. So we could say positive equals positive plus 1. So if, let me just do this properly. Yeah, so I'm just close. So this is kind of like a, if the mean is above 0, then add up like 1. So we're counting the positive cells, and then we're doing that for every single cell in that list of results. And then we could, now that we have that, we could say, where are we printing out? Okay, we're doing that here. We could do it underneath here. Print double labeled cells. And I would probably do this in a table, but it's a little bit more complicated to show for today. So I'm just putting it in the log. We could then just say positive. And we could also do at the same time a percentage. So we could just say, and we could put that in as hopefully that works. So yeah, and the spacing doesn't matter here. You can do a space after the plus or not. It doesn't really matter. It's just for readability. Okay, so hopefully I've done that properly. So let's just run that. Yeah, in the one there was a typo before. So now we're just basically dividing the total, the number of positives by the total, and then multiplying it to get a percent. And we can just type in here whatever we like. And that's a very quick way of just getting our this is listed here, but as I said, you could put this into a table. Yeah, hopefully that's pretty clear for everyone. There's still a little bit of time left. And so the next one that I wanted to sort of go through is just a slightly more complicated example, but just so you can start thinking about how you can expand on this type of work, is the example cells that we have in the final folder there, folder 3. So in here, these are ND2 files. So these are files from the spinning disk. If we open these up, Fiji has this bioformat, which really is useful for opening up things like CZI files and other formats. So like I would actually encourage you not to save as TIFF if you're working on these microscopes. Keeping them in the proprietary format actually lets you have a lot of extra information on the files. And you can open them up in Fiji very easily. And we sort of talked about this in the previous session, but we can just quickly open this image up by clicking OK. And this image is these are just like fibroblast cells that have a nuclear marker, some actin labeling, and this is a mitochondrial marker. And so a very common thing that people do in cell biology is want to study endosomes. Maybe they want to count the endosomes, but a common thing they'll also want to do is understand how far they are from the nucleus or how close they are to the membrane. And so this is something that like may seem very difficult or complex to tackle, but is actually very straightforward to deal with in a macro in ImageJ. And so I wanted to show you how to do something like this in the time that we have left. So just so we can have a look at this, again, like just to troubleshoot something like this, I would probably, pick a small region. I can use duplicate. If I wanted to just focus on one channel, I could unselect this and just pull out just this sub-region. And this is using the water objective. If we were really trying to analyze the mitochondria, we'd probably use the 100x objective on this spinning disk, but it's good enough that you can see the mitochondria fairly clearly, but not clear enough to get a nice segmentation result. So the first thing that I would probably do is we want to get rid of the background. We've got this low frequency stuff in the background here. We can just use a subtract background to get rid of this. And we could preview to see what this looked like if we were a bit unsure. But you can see like 15 is pretty good. You can always try smaller, but what happens if you go smaller is you may start to delete useful information. So this is fairly good. Another tool that's quite useful is in sort of enhancing. So what we're trying to do when we're segmenting these is just get a clear boundary of where the objects are. And so there's various tools we can use. For very challenging projects, we'll probably use machine learning and deep learning to get that's been trained on something like this to get a really nice mask. But for today, like just using tools that are within Fiji, Unsharp Mask is a useful way of just sharpening the image and getting a nicer boundary. And so we can use Unsharp Mask. This is the radius and this is the strength. So you can see if I put this on, you can see it's getting, the boundaries are becoming a little bit clearer. This is a nice way of just helping to segment these a little bit more easily. And for this, maybe a little bit larger. And we could even go a little bit stronger. So this is going to be a little bit easier to then put a mask on. And so then we could use, again, just the thresholding tool. And for something like this, Otsu is probably a good choice. So maybe we can turn this off again. You can see like it's pretty decent. There's still some that are joining together here a little bit. I wouldn't try and resolve this today, but just so you're aware, like some tools that you have available to you, once this is a binary image, we can do things like erode or dilate. So erode is going to shrink those objects by a certain amount, which we define in here. So we could say, if we just put one pixel in or one iteration in here, it's just going to do one pixel in. This is binary. So yeah, dilation is like where they'll expand. And one that could be useful, like probably in this case, I'm going to leave it, but you could use opening. That will sort of help to open up some of the gaps if you were really trying to separate them a little bit more. And another thing which we used in the previous session is watershedding. This is kind of trying to find boundaries between objects. I wouldn't use it in this case because it's pretty aggressive, but we can put watershed in. You can see how it will artificially break all these guys up. So maybe if you were trying to separate them a little bit more, you could use that. But I feel like that's a little bit too much in terms of separating. We've already sort of dealt with how to deal with the nuclei marker. Like we can just have a quick look at these guys. Just going to duplicate them. In something like this, we could do another medium filter. This is pretty clear cut. There's not much background, but we could, put a filter in just to clean them up a little bit. And then, again, Otsu is probably fine for this because there's just really a strong foreground on like a very dark background. It's not going to have any trouble finding a boundary. So that's how we could find the boundary for those. Okay, so what is also sort of interesting for this, like we talked about distances. So if we have an image like this, where we have a mask, we can ask, okay, how far are these mitochondria from the nucleus? And the way to deal with this is we can use a distance transform. This is, if we just search for distance, yeah, distance map. This is the basic one that you have with ImageJ. If I run this, in this case, it's going to go inwards. So this would be useful if we were doing a cell membrane. The intensity now, you can see it's 0 out here. I'm just looking in the status bar. So it's 0 out here. As I come in, it's starting to get higher. So this is distance in pixels. So it's very useful to like very quickly make measurements. If I want the reverse, then what I can do is just invert this image. So Control-Shift-I, and then run that again. And now I have a distance from the nucleus. So this is 0 in here. And as I go out, now I'm getting a higher value. Okay, so that we know how to do this. So let's put it all together in this macro. So actually, we're already halfway there. We've got a lot of this stuff already taken care of. We need to open the image. We need to split the channels. Actually, opening the image is going to be different. This is where we need to use bioformats. We can replace that here. So let's put that in here. It's just the same variables we used before. And you know, these are all the parameters that you could change in bioformat. So there's a lot of really great things you can do for other more sort of challenging projects, but we don't need to worry about them so much for this. But just be aware that they're there. We can use our sort of file name.
So as it stands, it's not doing anything different than just drag and drop?
Yeah, the drag and drop. So I think in the newer Fiji, sometimes it'll just use the main Fiji importer, but I found in the past, like calling the bioformats importer explicitly can be helpful for some data sets. I mean, Fiji is always updating, so just use what works for you, but it's good to know about calling this. Okay, and then we're going to rename it, and then we're going to split the channels, and we can, you know, let's just see what that would look like for us. This is our ND2 file here. So I'm going to just run this. That way I can see clearly what our channels are, C3, C2. Okay, so sorry, it's getting a little bit crowded here, but hopefully this is all clear enough. Let's deal with the nucleus. So first, so let's just separate this nucleus. I think we used the median filter before. I'm just going to copy and paste in this one. So actually, we've already got something that's pretty good here. So we can just make this 20. I think a stronger filter is better. And then we're duplicating it so that we have a mask for that. That way we can save it with the final result. And that way we can, you know, check to see how the algorithm's working. We used let's just quickly do it. We used Otsu. Actually, you can see even the unfiltered one is pretty good. So if you wanted to use that, you could. But filtering will generally be a little bit like more reliable for different data sets, especially if you've got different images with different conditions. So we're applying that. There's a way to make sure that it's calling the Otsu. So we just need to make sure that it's using Otsu. And then we're converting it to a mask. That's creating the binary mask that we talked about. We had to invert it, I think. And then we did the distance. So this is the basic distance map that we have to run. I think that might convert to 8 bits. So because we want to merge all these together, we want to make sure that they're all 16 bits. So if you're ever not sure, you can always just tell it to make sure that it's definitely going to be 16-bit. That way we can merge them with the original data. Okay, I think that's all we have to do there. The mitochondria, we had a few extra steps we had to deal with. So we have to select that window. So I think, so this was actually C3, wasn't it? C3. The mitochondria is C1. Again, like I would duplicate it. I'm just copying this. You can call it like Mito mask. We we did some filtering. I'm just going to copy and paste these. I mean, this was our background subtraction. If we wanted to make sure we could use the GUI for that, then again, we could just put the background subtraction here. And these are the variables we use for the Unsharp Mask. We won't do it today, but we could put these as variables in the GUI just by, we could easily just copy and paste this and make some changes to make it easy for someone to do. We have to do the thresholding. That was just, again, a simple Otsu threshold. So we can just copy this actually. Okay. Yeah, and actually then we want to analyze these particles. So just like before, we had this, but we want to analyze them. And so a couple of things we want to do. We'll have a distance image. Actually, so this is not going to be a mask. It's going to be distance. Actually, so let's duplicate it. We want to create the mask. Then we want to actually duplicate this one and have it as distance. So we have the mask and we also have the distance as a separate image. Okay, so we've got these guys doing the distance. And when we make the measurement of the mitochondria, so we'll want to measure on the distance image. This could be a little bit difficult to get it to do right now, but let's just try. We can say set measurements. We can redirect it to something. And when you're measuring distance, you should use minimum intensity because that'll be the closest distance. So that's the value we really care about for these measurements. And when I can copy this, and we just want to redirect this to our distance. So this is the distance one up here. I'm just going to type in distance. Okay, so that's fairly sensible. And we have to analyze the particles. So we could run this now. Or we could even use this image for this. We could set a size. Maybe we don't care about these tiny little specks. Maybe that we're considering them noise. So this is kind of up to you on the project, but we can just set a small size for this. Circularity is just how round it is. So, if there was some artifact that was very straight in the image, we could use this to get rid of them. I'm just going to leave that. We don't need anything in terms of an image here. We just want the results. It's complaining, but that doesn't matter. We've still got this command. So, and we want to, yeah, we're redirecting it. This is fine. Okay, cool. So we've got this kind of working. I know we're sort of doing this a little bit quicker now, but hopefully it's making sense based on what we've already done on the previous image. And finally, what might be nice is to actually detect the cells and then assign these mitochondria to every cell. That way we can get a good idea of like how many mitochondria are in every cell. So to do that, we can process the cells. And the actin labeling, it's not fantastic in terms of labeling the whole cell, but we can filter it and make it pretty decent. So if I just bring this, you can see it's covering most of the cell area. And we could do another median filter to deal with that. So I'm just going to put a filter in. There are many ways to do this sort of stuff. This is just like to give you a guide of like how to do a very simple image processing. And a lot of the, previously a lot of like getting things to work was figuring out the right combination of filters and processing to really be reliable across a whole lot of data sets, not just the one data set that we're looking at. It's oftentimes you can get something to work really well for one thing, but then as soon as you start working on 10 images, everything falls apart. And finding the right way of, or the right recipe is one of the sort of important aspects to that. And that's kind of really gone out the window, I think. More recently with machine learning and deep learning, we can get something that's very robust by training a network. And that's what we're going to look at next week. So this is still useful. It's still very important to know, but don't get too caught up on how well the results are looking for this, because we can get a lot better using additional tools. So we're just going to call this one the cell mask. I'm going to use a smaller filter. Same thing, Otsu, and then we just set the measurements. So I'm just going to, these are the ones that I used before. So I'm setting the measurements. When I analyze the particles, I'm using that same trick we used before. So I'm saying in situ, which modifies the image, and I'm using the count mask. That's where we got the different colors for the different cells. And I'm coloring it with Glasgow dark. So just like we did before, actually, just we're doing that specifically for the cells. Okay, we don't need any of this stuff. We don't need this. I mean, we could print like how many mitochondria, but let's just stick to just getting the distances. The final thing that we want to do is we want to merge these so we can save them. We're going to replace this. So this has got a few more things in it. We have our C1 image. This is going to be the mitochondria raw image, because that's probably the one we really want to see and make sure that it's looking good compared to what the masks are. Our distance, this is like how our distance from the nucleus. The nuclei mask, I think we call this cell mask, mitomask. So yeah, you want to make sure that these are all matching exactly to what we called our different images that we're creating. We're going to save that as a sort of, just as like a validation image that actually proves to us that what we're counting is actually really being counted correctly. And the thing that we wanted to get in terms of a table, that was there's two things really. The main thing, let's just stick with the main thing first, is the mitochondrial intensity on that distance, because that's going to be our distances. We could do another one in here that would measure the intensity of the mitochondria inside the cells, and that would tell us which cell those mitochondria are in. But let's just get this working, because I think we're getting pretty close to 4 o'clock. Okay, so I think we've added a fair bit in here. It's not uncommon that when you add a whole lot like this and you haven't been testing things out, that it's not going to run properly, but let's just see how we go. Actually, let's just see how this will work before we run it. Let's just duplicate the cell channel. Actually, what might be easier is to work on the mitochondria channel. So let's work on the mitochondria here. Let's duplicate this. And then with this channel, we can do a little bit of filtering. So what we can do, instead of median, what we can try, I mean, there'll be better ways of doing this, but what we can do for this one is just use a Gaussian blur and find something that will blur the mitochondria, but leave it the shape of the cell, maybe 15. And let's just put that in. And we want to do this on the mitochondria channel. So let's say select C1 input. Okay, so we're selecting C1 input. We're going to call the cell mask. We'll do the blurring. We're going to, let's look at the threshold. So if I do threshold, Otsu is a little bit too lenient. Like let's do Li, and we're getting, I mean, we're not getting the entire cell, but we're getting most of it. So I'm going to change that to Li. And if we want to just see what that would look like, let's just undo that filter. So I'm going to select to run the Gaussian blur. Actually, we can even include the duplicate. Let's duplicate it, run the blur, and convert to mask, and then put the cell mask or the count mask onto this image. So if we just select this and do command or control shift R, we can now see that we have like reasonable sort of cell masks. So all this together, we should now be able to run this on our folder. So select our data here, run. Okay, so it's finished running. And if we look in that folder, what we can look at, if we look at our, so the image we're saving here, the objects image, if we open that up, we can now see that we're getting cells as well as, I just Control Shift C, we're getting our cell mask, our mitochondria. The cell mask is not perfect, but gives you a good indication of how this could work. And the distance map, which we could look at, with a fire gradient or something like that. Actually, there's one other thing I wanted to point out here. When we're creating this distance map using just the standard ImageJ tool, it maxes out at 255. It's really meant for working with 8-bit images. You can see in the status bar here, I'm on the distance map. It's not a problem, I don't think, for this data set. Well, maybe it is, yeah. So you can see some here, they're all going to be 255. And the way to get around this is to use something that's other than the distance tool that's in Fiji. And the plugin that I wanted to show you is this plugin. If we look at it, Morpholibg. So this is a tool written by Ignacio that uses a lot of really nice filters and tools to do image segmentation. It's fantastic for doing both 2D and 3D segmentation. And they have he's put in here some really nice distance transformations. So there's some really useful ones for, they're all described here. There's some for looking along, like what we're doing for this project, looking from the nucleus or from the cell membrane, but also following along projections, which is really cool for neuron processing. Okay, and to install this, we would have to go into Help, Update, and this will update Fiji. But once this is finished running, we'll be able to add in additional plugins. And we can do that inside the updater here, Manage Update Sites. And this Morpholibg tool is underneath, right down here under IJPB plugins. So if you enable this, you'll need to restart Fiji to use it. This has a whole lot of fantastic tools, like we were talking about. And the ones for distance, they'll be underneath binary images. And we're using this Chamfer Distance Map. So if you call this function instead of the distance function that we use in Fiji, this is a 32-bit function. So you'll be able to measure distances as far as you'll have them in the biological image. So this is something that I'd recommend if you're working in these type of data sets. Because what I'll probably do is I'll share a link with some, like the scripts that we worked on today. So you have something that's working, and I'll include that little bit at the end for this one so that you could see how you could work, to get this whole thing working for the cells as well. And of course, this was just in 2D because, even going through this, it took us roughly 2 hours, but everything here can be scaled up to larger images, and it can be scaled in terms of doing 3D and complex things as well. And really, I think the power for this in terms of, especially if you're a biologist and you don't want to get too deep into scripting, you can see, hopefully it was clear enough today, how easy it is to use something like a recorder to work with images in a more interactive way, to understand how to get commands, and then use them in a macro so that you can process your data. And really, it's not until you have to process really heavy data that you need to start writing additional things like things in JavaScript to be able to do things in a more effective way. Just using the batch scripting will get you a lot of the speed for most of these things, especially for like smaller scale projects. Yeah, I mean, does anyone have any questions to wrap up with? And then, yeah, thank you for Inertia and Victoria for like helping me out there with when I was getting stuck. Oh yeah, and yeah, this has been recorded, and we'll post it. Like we'll just I'll edit it a bit so it's a little bit more succinct, and we'll share it so that people can refer back to it. Yeah, you're welcome.
And if we adapt something like this for what we're doing, and we can't get it to work, can you rescue us? Yeah, sure. Yeah, I mean, if you've got you're stuck on something, like you can see how easy it is to get stuck and how often those are just simple things. So if you do get stuck,
you can reach out. Also, there's a forum, ImageJ forum, where many of these sort of straightforward biological research questions are coming up pretty regularly. And so that's a great place to just go. If you just type it into Google, and I'm sure you'll find something. But otherwise, yeah, we didn't go today into like additional plugins, but if you're struggling with something, reach out and I can suggest like a different tool that might work better.
Thank you.
Yeah, you're welcome. Okay, we'll wrap it up. Yeah, thanks for joining today.